All right. Hi, everyone. In case you missed it, there's two videos before this. One introducing basically how we started making cables 30 some years ago. And the second one was about the materials used in the cables, some of the materials, how you can vary, like a good chef, cook up a cable with the various materials to make your own design. Now, I want to get a little more deeper into what, from my listening experience with working with these materials, how they sound. And I'm sure, for some people, this is getting crazy. It's like, you mean to tell me that one dielectric or one insulator sounds different than the other, or conductor sounds? And I'm telling you, yes, they do. And again, this is from experimentation. I found they do. And anyone that's not willing to believe that statement should try it for themselves. Get some different materials and see if you can hear it. And you'll need to learn, though, what you're listening for to begin with. You need experience in knowing what you're looking for. If you haven't got experience in high-end audio 2-channel systems, that's a prerequisite. Otherwise, you're wasting your time. If you're willing to learn, then take the time to learn what these things sound like and then go from there. It starts with a spark. You start to hear changes. Then you start to be able to quantify what caused the change. Look back, it's like reverse engineering. What did I just do that did that? Then can you do it repeatedly? If you can do it repeatedly, you pretty much came up with the fact that this is what A sounds like compared to B. Now, relative to what is where the experience comes in. It takes time, years. So anyway, back to this. On the sound of things, we'll start with something simple like the conductor material. All right. Copper tends to be the most prevalent conductor in cables, or at least a large percentage of the conductors are copper, and potentially with other elements or other materials like silver. Some companies use silver-plated copper, which again does set up a slightly different sound. You can change the thickness of the silver plating on the copper, or the quality of the silver, or the quality of the copper. Anyway, all of these have some effect. What you'll find, let's pick on copper. Let's start with copper to begin with. Copper is probably the most, I don't know if I'd call it neutral, but it's a fairly common material to use for wire and cable. In audio systems, it also tends to be the one that does the best job and overall in terms of not really going the wrong way sonically, either bright, lack of bass. These are things where conductor materials can vary. The purity of copper matters to a point. You might get out to 99.999 or 9999, 49s or so, and you reach a point where it doesn't matter anymore because all the other factors in the cable design have a greater effect than the purity levels. But purity of metals are huge in silver, copper, and any of these metals that are used in the cables. And one of the reasons is because of longevity. The less purity or the more impurities that are in a conductor, the more likely that conductor may vary over time or age. It could tarnish, depending on the environment it's in, whether it be you're near the ocean and it's salty. It could turn green, which I've heard happen on a lot of cables, cheaper cables in the past, where you have a copper that sits there, and if you have a clear insulation, you could see it. I'm sure people have seen this with zip cord over time. It's green inside. A primary factor of that is the impurities in the copper. Cause it to do that. If you take a very, very pure metal and put an impurity on it, like a skin oil or anything like that, it tends to just sit there and shrug it off because of its lack of impurities, and vice versa. So purity matters, particularly on the longevity of the conductor, and of course how it interacts with its environment. And let's just say purity is good, but it's expensive. That therein comes a price. The higher the purity of any of the metals, all right, or less impurity they have in them, the more it's going to cost to produce, and it gets pretty pricey. You ever look at anyone that does just simple thing like an oxygen-free copper, or OFC they call it, which tends to be considered to sound a bit clearer than standard copper. You can double or triple the price of a transformer just because you're running out of OFC copper in it. That's just because of the cost of the copper. So it gets pretty pricey when you get into the better metals. Now, sonically speaking, like I said, copper tends to be more of an average, fairly neutral sound. It reaches a point where it you can actually run out of clarity. Doesn't matter how good the copper is or what mine it came from or whatever. You reach a point where the clarity just stops. And the reason I know this is because I've taken it beyond that. So it happens. And I'm not saying it's bad. For a majority of people, copper is a great conductor. And when I hear that people have copper in their systems, I feel pretty confident that they can introduce components or other cables into the system, and it's not really going to mess with it too much in terms of it being the prevalent sound in the system. So it's a good general start. All right. So copper sounds pretty smooth. It's smooth through the mids. It's got pretty good bass response, good top end. It's just a good balance. Good wire to start with on any basic system in terms of a conductor. Silver, on the other hand, which obviously is a more expensive conductor, and again comes in different purity levels, adds its own flavor to things. Silver, for the most part, has a tendency to not do bass frequencies well or give you a perception of shift in tonality, where silver tends to sound a bit leaner or brighter than its copper counterpart. And I've seen silver cables that were made, guys that work with silver, which we've avoided it. But the companies that have worked with silver, who have really honed in on their own formula for the silver conductor, they sound pretty good. They're still a bit on the leaner side. They have almost like an artificial clarity to them. It's a little too bright. But again, you mix that with the right gear and speakers, and that little bit of tilt upward is fine. Tube gear, speakers that might be a little more uppity in the top end. Silver cables tend to flush out more information from things that tend to be lacking. Call it a little bit of an EQ of sorts. And again, it is something we tend to avoid in our stuff because I found that it tends to introduce too much of its own character. And then you're always trying to work around that, the character of that silver conductor. And, but again, it works for a lot of people in a lot of systems. And I consider it a bit of a tone control. And that's where you probably want to place it. We, again, create our own alloy wire called Alumaloy. It's a high purity aluminum and a high purity copper. And we can actually set the percentage of the metals. There's other metals in it too, but we set the percentage of metals. We set the annealing points, which affect the way the metals combine within the conductor material. And we've got that down to a science now where it's just, we have the raw conductor made, and then it's extruded down and stranded down into fine stranding for stranded conductors, or a large solid core 5 gauge. We have a version of it for a huge speaker cable, our top shelf speaker cable, which we've hand built from the inside out because no one's willing to insulate a 5 gauge solid core properly. So anyway, the conductor matters, and it sets up the sound or the bass sound for the cable. All right. So let's get into, and I should add, there's variables in between now. You have silver-plated copper, which a lot of companies use too, and that's more, as you would expect, it's more of a mixed sound between the two. I find it's quite variable. Like that type of conductor may sound different in one system than the other because it's just, I don't know why. It's just a mixed sound. And again, I've avoided silver because I always saw where it went in a system. And I have stories on that where, we couldn't get some preamp to work right in a system. And it turned out the manufacturer happened to customize that one preamp with silver internal wiring where he normally would use copper. And go figure, right? And we're all scratching our asses going, why isn't this preamp working in a system like we expected to? And it was because of the wiring, the internal wiring they used, and he forgot about it. It wasn't a normal product he'd make. So anyway, it's just things like that where you realize it's something I tend to want to avoid, particularly in a really high-res, extremely well-balanced system. But again, you could use it as a tone control, and it can have an effect that's positive if that's what you're after. So onto the dielectrics. The insulation on each conductor, the high-tech term is dielectric. And the most common insulator used is PVC. It's used on a majority of the cables that are out there in commercial use, your home wiring and so on. It's cheap. It's inexpensive. You can use a really low grade of it, and it works. It acts as expected. It insulates the wire to a specified voltage at a certain thickness. So it's used primarily in, all the cables, extension cords, your home wiring, all the commercial stuff. It's all PVC, with the exception of anything that's specialty, right? So it's a very popular conductor. In audio, it also tends to be the worst sounding conductor. And it could be made to sound good. There are actually somewhere around 10 levels of the quality of PVC used. And if you get into the higher quality of stuff, it actually doesn't sound bad. We used it because of fire ratings and voltage ratings. We used it in a home theater cabling, the bulk wire we used to make years ago called Super Blue. Anyway, it's a type of conductor where, the type of insulator where in some applications it's perfectly acceptable. But when you want to take it to another level, it's not what you want to go with. So that's PVC. That's just general case stuff you find everywhere. It's ubiquitous. Moving on from that, you get into your polys. Polypropylene, polyethylene. Now, here's where things get interesting. Those are a huge step up in terms of how the conductor sounds, in terms of it's allowing the ability of the conductor to sound like itself. I'll give you an example. You take a conductor with no insulation on it, all right? Listen to it, bare. Obviously got to keep them apart, otherwise the cable is short. Insulate, keep them apart somehow. Listen to it, bare wire. Now you add insulation to the same wire, listen to it again. And now you start to characterize what that insulation or that dielectric's doing on that conductor. And they all have a different thing of what they're doing. They all have a different sound. All right. So now the polyethylene and polypropylenes, they tend to be very good for audio applications. And again, you can apply these insulations in many ways. There's tubular extrusion, which just floats the conductor inside all the way through pressurized extrusion. It forces it into every nook and cranny and everywhere in between. Different flexibilities because of that and different sonic traits. So the way that the dielectric intimately contacts the conductor matters. And some people just like to float it and not have it touch, because they like the conductor the way it is. And that's that designer's choice, preference with the cable. And others are the opposite for various reasons, all right? And it's particularly with stranded cable too. If you float a stranded cable into a tube, the strands are going to loosen up over time. They don't make contact with each other so much. That opens up for other issues. The cable will start to sound different over time. All the various strands are more susceptible to the environment. So there's all kinds of things that you got to consider in designing a cable. It's not necessarily just the sound, but it's also got to hold up over time, and it's got to be durable. And it shouldn't really vary in sound over time other than through the break-in period at the beginning. So anyway, so now the polypropylenes and polyethylenes probably account for a lot of the upper end of cable design in terms of for audio. There's negatives and positive in terms of their melting points and solderability and so on. They tend to melt easier. Not as much fun to assemble cables with these, but that's the problem with the guy assembling the cable, right? Bottom line is that they are probably some of the best sounding insulations you can use. Certainly a noticeable step in terms of clarity and the ability to let the conductor do what it does. Definitely a step above your typical PVCs. Then you get into all kinds of exotic things. There's exotic insulations. And again, as we're going up with this, price, believe it or not, is commensurate with sound. Why? These are very highly tweaked dielectrics. They're designed to have specifications that are beyond the norm. They were made for other applications. They weren't made for audio, right? And it just so happens that these, whether it be high temperature specifications, durometer or stiffness or whatever the spec is that they were looking for, they created these dielectrics for, they're expensive because they're not high volume applications, but they're just very expensive to make. And so you get into beyond that, you get into your PETs and your Teflons and those type of dielectrics. Now those are much higher efficiency insulators. They were designed to be thin and have a very high voltage breakdown, which means you could make a cable thinner and throw 1,000 or thousands of volts through it, and the dielectric will insulate the conductors from each other. So it gets into more of a specialized dielectric. The PETs, to me, though, have more of a upper mid-range glare to it, and it's never goes away, even if the cable played for a while, and it's always present. And again, that could work to your advantage if you have a system that's lacking in that area or the room or whatever. But again, we use them sparingly. We use them in applications where we might need thin. Like, for example, the ground lead on this is PET. The blue lead is PET insulated, so we could keep it thin. We didn't want the ground lead to take up and bulk up the cable. I think it's a 12 gauge in here. It doesn't look like it because the insulation's thin relative to the other cables. Same with the larger cables in here are 10 gauge stranded. We'll get into that next, but that's a Kapton dielectric. Kapton, again, is very, very good dielectric. It doesn't need to be thick to set up the voltage rating. We call it highly efficient at what it does. Where PVC, on the other hand, PVC cords, like I said, in the lower end of things, you really need 10 times the thickness to insulate the same voltage compared to like Kapton. Don't quote me on that, but it's a lot. It's a big difference in thickness versus PVC versus a Kapton versus a PET. Again, that's what these things were designed for, was to act as dielectrics and insulators. And the more expensive ones are better at it than the cheaper ones. Makes sense, right? Anyway, with PET and Teflons, I can almost, when I go in a room, I can almost pick out if someone's using it as an insulation because I'll hear that characteristic glare that I'm so familiar with. And, it's noticeable. And some people will blame other things in the system. And it can come out more depending on the electronics you're using. Like solid state can, a good big solid state amp will probably push that glare more at you than tubes would. But it depends on the tubes you're using. So again, it's a bit of a tone control in that upper mid-range area that some people like. And it might work for them, it might not. Something we tend not to use much of in dielectrics on the audio carrying leads. There's all kinds of dielectrics that were designed for aerospace and use, like to have thin insulations in the wiring carrying signals in aircraft. Going out to space. I mean, if you're going to carry a signal, you got to have some serious temperature extreme ratings on the insulations on them. All right, planes are an issue. They flex, they bend. You got to have the ability for that insulator to bend millions of times without breaking down and having an arcing and causing a problem. So there's all kinds of reasons that why someone or a company or a manufacturer or an engineer would spec one dielectric versus another given a use. In our case, it's primarily about the sound and also the safety of the cable. All right, and in power cords in particular, we want to make sure that these things don't ever cause any issues. Like this bad boy, we want to make sure the dielectrics are safe. They'll always be safe. In any application you're going to use it in a home setting, safety is huge. So the dielectric choice can't always be just about the sound. It has to combine sound and safety, and then of course longevity. Same with the assembly of the cable matters too. The way you assemble the ends, the way you strain lift the ends matters. Particularly on things like power cords where they're going to bend around, you put shoving furniture against it. These are things you have to consider into the overall design of the cable, not only the sound, that it can take that abuse and not cause any potential issues down the road. And again, that's part of the selection of the dielectrics and the insulations. How thick do you make it? If you make it too thick, you're spending a fortune on that material and it's not doing you any good. You make it too thin and it cracks or breaks and then the cable fails. So there's all kinds of specifications that you have to learn in order to make this a cable last in its particular usage case. So anyway, on from Teflon. So like I said, the Teflon's more of a mid-range glare. Kapton I found to be a phenomenal dielectric. It's one of my favorites. We use it in these our higher end interconnects. We use it as a polyimide. It's a coating on our conductor materials. And on our high end power cord like Captivator Light and this Illuminata, we have huge conductors in there that are stranded, and we use the Kapton. It's wrapped onto the conductor and then sintered or heated to make it one piece insulation. It's also very expensive stuff to have made. And I think we're down to there's only one vendor left in the country that actually works with the Kapton. It's basically gone to China and there's nobody left. So anyway, it's a really, really expensive dielectric to apply. It has particular properties in a power cord in particular that I fell in love with. And it just seems to just allow the alloy wires we use in our power cords to let them do what they do best. There just seems to be a lack of absorption. It's not removing any information. It's really ultimate. It does have just a very slight bit of glare to it, but you have to know it to hear it. And so, and it does take a long time to break in. It's very benign, very slow to change as the cable's being used, but it does break in. And when it does, it's damn near invisible. It's one of my favorites in terms of power cords, and we do use it on our upper end stuff. And so anyway, that starts to give you an idea of where I come from in terms of how we can mix and match these various materials and conductor materials to come up with an overall sound for a cable. All right. You combine that with the type of solder you used, which is critical too. The way you solder, the way you apply a wire to a contact matters too. You don't want to have gobs of solder in between a conductor and a contact. You want to try to make a mechanical connection first, then use the solder to maintain that mechanical connection. So, there's tricks you learn along the way, and it takes years to really, really fine your art, where every cable that's assembled by that guy or a group of guys who are trained the same way sounds the same each time. Whereas the opposite would be true, where if you give a cable and connectors to 10 different people, you can actually hear the difference in how they assembled it and probably see it over time. Some of them will break contact or connection, right, because they didn't quite make they might have made a cold solder joint, didn't quite do it right. So there's a number of factors that play into the labor side of this and, how well it was assembled. Bottom line is that we can construct a cable to sound any way we'd like, to a point. It's not the same as putting a blanket over a speaker and so on, although I've heard some cables that sound like dog shit. But bottom line is that we can make a cable sound any way we like, all right? But the goal for us is to be as close to the source as possible. How much closer can I get to hearing into the tonsils of that singer? How much closer can I get to hear that string decay over time in proper timbre? All these things are what we've sought over the years, and we've refined it down, our art down to the current products, and transposed that knowledge into creating Abyss headphones. So we use material science in the headphone just as much as we do in the cables, and it's what's allowed us to do what we do. So I appreciate everyone for watching. Thank you for your understanding. Remember, please be cool on the comments. We're all human beings, and we need to get along. Take care.